Alright, in this video we're going to take a look at the hotel's networking and SSL certificates. So this is a training designed to bring someone who's not necessarily familiar with networking terms up to speed with some of the more common terms that you'll see in a hotel's landscape and what they are. We're also going to look at the SSL certificates, which are the certificates used to create a secure website. And we'll be taking a look at those in the second part of this training. So, first on the list of our common terms, we have LAN and WAN. The LAN is your internal network, and the WAN is shorthand for the internet. So, LAN is local area network. Basically, it's everything from your router to, or from the router on the inside of your network. So all of your computers, phones, printers, anything else you put on your network inside the building is going to be your local area network. The WAN or wide area network is just the shorthand for everything that's outside your network. So that includes, everything on the internet, every other office or hotel that might be out there, anything else on the outside that you don't have control over. Other common terms you're going to hear are VoIP and SIP. So VoIP is a generic term meaning voice over internet protocol. It's just a way to say voice over the internet. So any method that you use to transmit your voice over the internet is technically VoIP. SIP is a specific method for setting up calls over a network. So SIP is what we use on our SIP phones in order for you to make a call from one phone to another. There needs to be a protocol used to start that call, to ring the other phone, to have that phone or have the system know when that phone is answered and begin the audio, and then have information on if that call was transferred or ended, things like that. All of those things are covered by SIP. And it's just a network protocol that handles all that information and keeps track of all the calls to make sure that calls don't end in the middle of them, and calls that have ended do not continue on, sucking up network resources, things of that nature. Other common terms, we have SIP trunking. So trunking is just a term that means your call path to the outside world. In the old days, we had PRI, T1, or POTS, which is plain old telephone lines. So those were the ways that you could pick up the phone and call, the local pizza place, for example. You need to talk from your PBX internally to the outside world. We now also have the option of using SIP trunking, which is the same concept as trunking has always been, but we're just using a SIP provider to be able to connect those calls that you want to talk, use to call down to the local pizza place. You're just using the internet to do that versus a PRI line or copper lines through your old telco. RTP stands for real-time protocol or real-time transport protocol. It's just how voice is transmitted over the internet. So this is in contrast to pretty much every other protocol on the internet. If you are downloading a file or watching this video right now over the internet, it is not a real-time protocol because you can download the file, save it, and view it later. This video also buffers. It will download, and if your internet cuts out, the video will just stop after the buffer runs out. But we can load the video before you watch it. In a phone call, we can't do that. The phone call has to have a real-time protocol, meaning, what's being said needs to be transmitted immediately to the other end. And there's very little buffering going on. There's very little error correction, things of that nature. So it's just a different type of protocol. Router and firewall. This is a device used to help you build, maintain, and secure your network. So on a network, the controller of the entire thing, the one that keeps everything in line, that keeps a list of everybody's IP addresses, and just keeps things orderly, is your router. The router also normally contains a firewall, which will protect you from unwanted traffic from the internet. as we know that sometimes devices or people on the internet don't have your best interest in mind and want to access information they shouldn't have access to. The firewall is the thing that prevents that. So what does a hotel's network look like? So the first thing you have again is your router. That is the controller device for the network. It talks to everyone and makes sure everyone plays nice, keeps track of who's who, and if there are new devices that join the network, it will be the one to assign those new devices an IP address, and again, keeping the network orderly. This router is usually connected to the internet via a standard, for example, Comcast modem or some other landline connection, cable modem, or maybe a fiber connection. But that's how it can talk out to the internet, and how anything on your network can then talk out to the internet. We have also seen that in some cases, you will want to have more than one internet connection to your router. This is designed to create failover should the primary internet connection go down. So if Comcast were to have maintenance and their router goes down, or their modem goes down, your router would then switch over and use for example, a 4G source, cell phone-like connection up to the internet, so that the hotel and their SIP trunking and SIP phones stay online and can continue to communicate. In addition to your router, you will usually have one, or in many cases multiple, switches. These switches are usually devices that are less intelligent than a router, and their job is to simply provide additional ports. A router normally only has 4, maybe 8 different ports on the back of the router for you to connect devices to. And in a hotel, that's just not going to fly. You need to have many more devices physically connected. So that's why you use a switch. It just allows you to have more ports to connect more devices. And the switch does have some basic logic in it that will help lighten the load on the router. For example, if someone on port 1 of the switch wants to talk to someone on port 3, that traffic is just routed through the switch and doesn't go up to the router in most cases. So things connected to your switch are usually computers, your SIP phones. If you're going to have a SIP phone, it's probably also a good idea to have a PBX that's connected. Also, your property management system and many other things can be connected to your hotel's network. Network planning. So when you are going into the hotel for the first time and you're charged with changing out their phone system for a new IP system, there's going to be some questions you want to ask to make sure you have the information you need so that on the day of install you can go in and get things done quickly. Number one, you want to ask, how am I getting internet? You need to know which port on your switch to plug into, and if you have a public non-netted IP address. Those things are usually important. How fast is the internet? If they say, hey, we have a DSL modem, that's not going to cut it, especially not for SIP trunking. They're going to have a lot of issues with call quality if they use DSL. So you've got to use something better. Is my room and admin phone cabling going to be ready? If the answer is no, then you maybe want to push back that install. Do all the admin locations have Cat5e or Cat6 cabling ready? Again, if the answer is no, or that'll be done later, you just need to be aware of that there may be work that you can't do on your initial install that you have to come back and do later. And then, where is the cabling terminated? This is a more recent phenomenon we've seen where a new build will not terminate all of the networking or TDM cabling to one room. They'll terminate it to separate IDFs on each floor, or maybe every other floor. And that is a nasty surprise to find out the day of install. So you're going to want to make sure you ask those questions before you do the install. Make sure you understand, okay, where is all my cabling going to actually be terminated, so that I know where all my switches, routers, and everything else should be located. Hardware. Again, we have the router firewall. Popular brands include Fortinet, WatchGuard, and Netgear. You're going to need to just pick a router that works for you, that's familiar to you, and that supports your needs. It's no good to buy a device that's recommended by everyone that you can't use. So make sure that you get one that you can understand, that you can use, that makes sense to you, that you can set up and support. PoE switches. It is very, very common to see with SIP phones that you have a PoE switch, which just stands for Power over Ethernet. It's simply a way to power the phone without requiring a power adapter and a power cord near that phone. So it just makes your install a lot easier and makes the phones a little bit neater. They don't have extra cabling in terms of that extra power cable needed at every single location. Obviously, your SIP phones, VTech, Polycom, Yealink, etc. Those, much like the router, you're going to want to pick a brand and model that you're familiar with. VTech, Polycom, and Yealink are all excellent brands. They all do very well on the admin side, and it's just going to be determining which one you get is more of a customer request and your familiarity. If you've used Yealink all your life and you're familiar with it, by all means continue to use it. It's better to use something you're familiar with than something that may be slightly cheaper that you have no idea how to use. That's going to hurt you a lot in terms of support and setup. A couple of firewall tips. When you set up your firewall, if you're using SIP trunking, you need to open port 5060 and the RTP range 10,000 through 20,000 UDP. This 5060 allows for the SIP protocol to allow calls to be set up and taken down. And then 10,000 to 20,000 is your individual channels for voice. So once that call is set up, you will usually use one or two channels in between 10,000 and 20,000 for the audio of that call. You're going to want to disable all SIP ALG and other session helpers in the router. They usually do more harm than good unless you are very familiar with what you're doing and you know you need them. Usually turn them off. The problems that can be caused when you leave these on are one-way audio issues or no-way audio issues. So they're fairly easy and obvious to understand, that you have a problem, but sometimes it's very difficult to find where in the router to turn these things off. Use ACL whitelist to allow access to your system only from approved IP addresses. I cannot stress this enough from a security standpoint. The best security policy that you can have is to set up strong ACLs. And what this is basically you tell the router that from the outside world, the only people allowed to talk to my system are from these specific IP addresses and no other. That will make it so that a hacker in some foreign country or even a local one won't be able to even attempt to access your system. The firewall will simply look at that traffic and say, nope, you're not on the approved list. I'm not even going to talk to you. I'm not even going to look like I'm alive. I'm just going to drop your packets off the face of the earth. And that way a hacker has a much more difficult time even understanding that that IP address is alive and there's something there, let alone what it is and trying to hack into it. You're also going to want to use DHCP option 66/160 to auto-provision your phones. There is another complete video on the SIP auto-provisioning and our auto-configuration. If you have questions on that, I encourage you to take a look at that video. Testing and documentation. You're going to want to verify that two-way audio exists on all SIP phones and SIP trunks. You're going to also ensure just a general good quality of audio. Test more than one call at a time on your SIP trunks. So just because one call worked, you want to test at least two at the same time to make sure you don't have any problems with multiple calls. You also make sure your system is accessible remotely. You want to make sure that it's accessible from at least your office so that you can IP into it if there are change orders. But it's also a good idea to let Phonesuite know. You can just shoot us an email at support@phonesuite.com and say, hey, my system is up at this IP address. Can you log in and make sure that you can at least access it in case I need support from Phonesuite? Remember to document what port you're using for your LAN and how to and who to contact, rather, should you have any questions. And this documentation is not needed for the next week or two. It's going to be the documentation you need a year or two down the line. If you're troubleshooting and you can't remember, okay, what port did we plug into for WAN, things of that nature, especially if you need to walk someone through it on site, you're going to want to document that really well. So that later on you're not scratching your head trying to figure out, okay, where where were those cables plugged in if somebody went in there and just unplugged stuff at random, which has happened. Next, we're going to talk about SSL. And so in short, SSL is a way to be reasonably sure that the website you're talking to is secure and is the actual person you want to talk to and hasn't been hijacked or your traffic isn't being rerouted inappropriately. SSLs use encryption between the website host and your computer. So this prevents or makes it much harder for someone who is in between the server you're talking to and your computer to be able to spy on your traffic, listen to it, and understand what you're doing. For example, if you're logging into your bank account online, you want to make sure, at least be as sure as you can, that someone in between you and your bank isn't spying on that information and taking your password and login information. That's what SSL does. It also uses a third-party to verify that the encryption and the identity of the site is correct. And this is where Phonesuite was a bit lacking in our initial systems. We would use an encrypted certificate so that the communication between the Voiceware server and the computer was encrypted and was very hard to spy on and pull any information out. What we were lacking was the third-party identification, which doesn't make the encryption invalid. It just makes a website very suspicious because that's not typical practice. You want a third party to verify that everything is on the up and up, so that if the website you're connecting to had been hacked, if you don't have that third party identification, it's more difficult to understand that something's wrong. So Voiceware by default uses a self-signed certificate, which again is a little bit atypical because normally you want to have third-party verification, but with self-signed you don't have that. While it was completely secure, it is not verified by a third party and thus suspicious, and we now have the ability to install a free certificate signed by a third party. So what does this mean to the actual customer? Why is this important at all? Well, if you've ever logged into one of our Voiceware systems, you may, and the first time you log in, notice a warning like this, and this comes from Firefox. And it's a warning that says that your connection isn't secure, which is not exactly correct. It is secure, it's just suspicious because it's a self-signed certificate. This warning was annoying to the end users because, especially on Chrome, even if you added an exception, it would go back and give you this warning again after 30 days or 60 days, something like that. With Chrome, you lost the ability to permanently add an exception like you do with Firefox. This endangers more trust from the end user. So if you have a signed certificate, they're not going to see this warning. They're just going to go right through, and it's not going to make them a little bit more suspicious on what's going on. So if you want to do a fully qualified certificate, what you need first is a fully qualified domain name. And this is something that Phonesuite can't help you with. You need to be able to set this up on your own. The reason for that is you need to use your domain, your company's domain, for your fully qualified domain name. So for example, Phonesuite uses the fully qualified domain name of voiceware.com, and that's ours. We can't really share it with anyone, and you as a reseller are going to need to get your own, and that's something you'll need to do on your own. There are many places out there you can get them, and the cost of doing that is not very high. You're looking in the $30 to maybe $150 or $200 a year in most cases. Once you have that, though, you can start doing for example, here I have hannah.voiceware.com. So once you have voiceware.com, you can start adding what are called A records of specific names that are subdomains of that voiceware.com that'll point to a specific site. Once you have this, once you have a hannah.voiceware.com or a marshaCode.yourname.com, once you have that information, then you can go and download the document called Installing SSL Certificates on a Voiceware Server for Resellers. It's a document that's available on our reseller portal, and this document will walk you through everything you need to do in order to install this certificate. You'll just have to download the document and follow the process on how to set it up. And that concludes our session. So in this session, again, we took a look at some of the common terminology that is found in a hotel, and we also looked at the signed certificates, SSL, and how you set that up. So we hope you enjoyed this look at those topics, and look for more videos on our YouTube channel here soon.